So when we do the clustering, we can understand the data, and there are many applications. For example, in the biology, you can see some kind of taxonomy. Taxonomy means, when you are studying the biology, you know about the species, genus, family, order, class, phylum, kingdom, which is the highest level of the biology. So they try to understand the living things based on the similarity. So if they are similar, then maybe they are in the same species. If they have another similarity, they are in the same genus. If they have another similarity, they are in the same family, and so on. Information retrieval. So if you are if you have interest on the document, okay, so you can cluster document. Land use. So if you have the information about, like say, the satellite, so we can identify the areas of similar land use in an Earth observation database. In the marketing, so you can help the marketers discover distinct groups in their customer bases. So yeah, you can know what customers you want to target. Maybe you want to target the high salary person or the low salary person. You want to make the city planning. So you can identify groups of houses according to their house type. Or maybe we know about the value. So if it is the villa or apartment or just a common house, and it is based on the geographical location. If you are doing with the earthquake studies, if we know where is the earthquake epicenters, then we can make clusters along the continent faults. So maybe we know that what is the location that should be aware with the earthquake. The climate. We can understand the Earth climate, find patterns of atmospheric and ocean, and other things like economic science. We can have the market research, and we can do clustering. When we are doing the clustering as a pre-processing tool, so we can make a summarization, or we can make the summary of our data. The summary of our data, you can use like pre-processing for regression. So before you do regression, you can make clustering. Or after you do with the pre-processing, you want to make PCA. You still remember PCA? PCA is principal component analysis. Or we can do again, after we do with PCA, we do classification and association analysis. So you already learned all those tools. We can do clustering for the image pre-processing or image processing. There's word factor quantization. So the factor quantization means, if I have, let's say this is the original picture, and maybe the color is too bright and the size is too big. So I would like to reduce the image size. We can do clustering, so the color can be reduced. Now the color becomes only 12, and the image size is now reduced. Even though the color reduced, we can still see the image. And let's say I want to compress the image using the PC reduce. PC means the PCA, principal component analysis. So we want to find the principal component, and we can reduce the image with a higher image, we can have the size is smaller. So yeah, there are many ways to make the image reduction, and one of the way is using the clustering. Finding k nearest neighbor. And usually we call this is the k and n. K and then nearest neighbor means the n. We want to localize the search to one or a small number of clusters. Let's say I have the x and I have the y. So if I want to say that k equals to 3, I have this data. What should be the class of this data? Is it class B or is it class A? Class A is the star, the red color, and class B is the triangle. So if you are the data analyst, what would be this class? If you look at this one, then there are two triangles in the range of this circle, and there is one star. Then if you understand the voting mechanism, then 2 is higher than 1. Then we can assign this to the class B. Because when we have k equals to 3, 2 of them is B and 1 of them is A. So we assign with the majority, which is B. So this algorithm, the K and N, we usually use odd number, like 3, 5, 7, 9, 11, 13. Because when we have the similar or the tie, let's say we have, if we use K equals to 4, then if there are 2 class B and 2 class A, then we cannot decide. So that's why the K and N usually use the odd number. We can use clustering as the outlier detection. So the outliers are often viewed as those far away from any cluster. Now, there is another question. If we want to make a clustering, what is good clustering? So we need to understand the quality of clustering. A good clustering will produce a high quality clusters. High intra-class similarity. High intra-class similarity means the object in the same cluster should be high. Intra-class, it should be high. And we call interclass. This is the class 1. This is the class 2. So the interclass, it means between different class. If it is intra-class, it means it is in the class. It is in the class. So I can say this is the intra-class, and if it is in between, we call this is inter-class. Okay. The high intra-class similarity means the cohesive within clusters. So it should be in the within cluster, and it should be distinctive between clusters. It should be distinctive. It should be different between clusters. So if you look at this diagram, the different the intra-class variability, so maybe should be high. So if the intra-class variability is high and the inter-class variability is low, then you can see like this one. This is the best one. Because the clusters is really grouped in different groups. But if the intra-class variability is low and the inter-class variability is high, yeah, it happens like this. Some of them are overlaps. So this cluster is not that good. If the intra-class variability is high and the inter-class variability is high, you can see some of them are overlapping. This cluster is the worst. Everything is overlapping. So based on the definition, this is the high quality clusters. But the quality of clustering, it can also depend on the similarity measure. Do you still remember the similarity measures? We have Minkowski distance. What are they? When h equals to 1, it is Manhattan distance. When h equal to 2, it is Euclidean distance. Okay. When h equal to infinite, it is supremum. Okay. So this is the basic similarity measures. We also know another similarity measures. We have the Jacob similarity. We also know the cosine similarity. Okay. And later on, when you do it orange, there will be other kind of similarity, like Mahalanobis similarity and so on. Okay. So actually there are so many similarity measures, and because they are different, the clustering result is also different. And how we implement, and how we can discover some of or all of the hidden variables. Okay, so as I mentioned to you, this similarity and the similarity method, it will affect the result. It can be the measure of the quality of clustering. Similarity is expressed in terms of distance function, Dij. The definition of distance function are usually rather different. For the interval scale, the interval scale is any numerical number, and it's also different for Boolean. I guess you already know how to measure the Boolean, like the example in the exam, asymmetric binary. Okay. So you know how to measure asymmetric binary or symmetric binary. Okay. How can we measure the categorical value? Yeah, there's also another similarity force. How if we have the ordinal ratio? How if we use the factor variables? So the difference of the measures will affect the quality of the clusters. Weights should be associated with different variables based on the application and data semantics. So yeah, sometimes we need to assign weights. So the quality of clusterings there is usually a separate quality function that measures the goodness of clusters. So we will check later what are the quality functions is. And yeah, for now, I can say that it is hard to define similar enough or good enough. And the answer is typically highly subjective. So it depends. It really depends on your data. It really depends on the expert. It really depends on the knowledge and etc. So the quality of clustering, yeah, it will be very depending on many things. So what the consideration for cluster analysis, we have the partitioning criteria. Partitioning criteria means if I want to partition means I want to separate the data. So if this one is the single criteria or single level, let's say I have a box. So I can separate into two, horizontal and vertical. And then I can split again with the vertical. Then we have the single level. Or we can have the hierarchical partitioning. The hierarchical partition means the low level is all the data. So the data here, now I would like to merge it and make it as a new set. Those two data, I want to merge it and I make it into a new set. So this data seems to have similarity and we will make a new set. So we have the hierarchy to create the group. Or we can see the cluster analysis based on the separation of the clusters, whether it is exclusive or non-exclusive. Exclusive means one customer belongs to only one region. So this is exclusive. So it is in one region. It is in one region. It is in one region. But non-exclusive, for example, one document may belong to more than one class. So this is an example, non-exclusive. We know the black color. Maybe I want to create this one, but if I want to create another model like this one, then some data are overlapping. So the document, yes, in many times document can be the best example. For example, these days we have the news about North Korea missile. So the North Korea missile news, it can be about the political news, it can be about international news, it can be about the security, national security news. Yeah, so there are many classes for the same news. Similarity measures. So whether it is a distance space, the distance space is based on the Euclidean, or it is based on the road network, or it is based on a factor, or using the connectivity. The connectivity means whether we use the density or the continuity. We can also use another way for the clustering space. Whether we use the full space when the data is in the low dimensional, or we use subspace if we have high dimensional clustering. Dimension means the attributes. Okay. If it is low dimension or if the number of attributes is small, then you can use full space. If the number of attributes is high, you can just use subspace. So there are some requirements and challenges when we do the clustering. First is the scalability. Scalability means the clustering all the data instead only on samples. It depends on your laptop. It depends on your computer. If you have like 10 million data, maybe it's not good to run the clustering with all data because it's too big. So you can just do samples. In your first assignment, we know how to make samples. But it depends whether you can do samples or use all the data for the clustering. There's an ability to deal with different types of attributes. So you know about numerical data. You may have binary data. You may have categorical data. You may have ordinal data. You may have linked data, or you may have mixtures of this data. So when your data is mixed, of course, it is more challenging. Constraint-based clustering. Constraint-based clustering means the user may give inputs on constraint. For example, if I have this kind of data, okay, I can give constraints. This data and this data cannot link. So I cannot make the link between those two data. Maybe this is the data from one country, this is another country, but those two countries has no agreement. Then, yeah, you cannot link. This country and this country, they have agreement. Then, yeah, they can make a link. So there's some constraint that you cannot avoid. So the clustering should be based on the constraint. Or you need to use some domain knowledge to determine the input parameters. And how we can interpret and how we can use the clustering. So it's also a challenge. The other challenges is like, how we can discover a cluster with arbitrary shape. This one, arbitrary shape. For example, this shape is a little bit strange. But can we find this shape with the clustering? Yeah, actually, yeah, it is able. We can make this clustering because this is arbitrary shaped clusters. Ability to deal with noisy data. So if we have some outliers, we need to have one approach to deal with the noisy data. Or some kind of incremental clustering and insensitivity to the input order. Or the high dimensionality data. So if we have a lot of attributes, then we need to think which attribute is important and which attribute is not important. So some major clustering approaches that you already know, the partition. Partition means we construct various partitions and then evaluate them by some criteria. For example, we want to minimize the sum of square errors. So let's say we have this data, and in this data, I can make partition. So this is the first partition, this is the second partition, the third partition, this is the fourth partition. Or there is another approach, we call it hierarchical approach. So we can create a hierarchical decomposition of the set of the data using some criteria. If we call the data from the low level data, we call it this is agglomerated. If we start from the whole data, we call it this is the division. So later we will learn about the Diana, Agnes, and etc. Density base. Density base, it is based on the connectivity and density function. So this one is an example of moon shape. We call this is moon. Moon shaped data. If we have moon-shaped data like this one, then it is not possible using the partitioning. When we apply the partitioning, the result is something like this. So we need to apply the density base. If we apply the density base, then the clusters will be based on the density. Grid-based approach. We have multiple level granularity structure. There's another kind of approach, we call it model-based approach. The model-based approach is a model is hypothesized for each of the clusters and try to find the best fit of that model to each other. So let's say I know this data here, and then I know the data here. So I have the model. What is the model? The model is this one, the circle. So this is also another model. So I want to find how many data that fits into this model. If there are many data fits with this model here, then I would like to make the cluster in this place. If there are a lot of data clustered in this area, then I would like to make the clusters in this place. We can also use other approach like frequent pattern base. It is based on the frequent patterns. You are based on the association rules. So the association rules use the frequent pattern or frequent item set. User guided or constraint based. So the one that I mentioned to you, we can make some constraint if it is specified by the user, or maybe there is a specific application on it. Link-based clustering. So link-based clustering, it is based on the objects that are linked together. So let's say if you have the data about Facebook or Twitter, or maybe you have Instagram. So the Instagram is connected to another person. Then you can have link. So the link, let's say this is the graph. The person number 4 is connected to number 2. The person number 3 is connected to person number 2 and 4. And the person number 2 is connected to person number 1. And I would like to know what is the similarity between those people. Then I can make some kind of scores, because this is the similarity scores. And based on these scores, we can make a cluster. Okay, learning check. Cluster analysis is to find similarities between data according to the characteristic found in the data and grouping similar data objects into clusters. True or false? True. Find similarities between data according to the characteristics found and grouping similar data objects into clusters. The answer is true. Okay. What is good clustering? Based on the definition, we have the high intra class, and then we have low inter class. The high intra class means it is cohesive within data. The low inter class means distinctive between clusters, or maybe we got this is cohesive within clusters. What are the considerations for cluster analysis? We have for the partitioning, we have the exclusivity or the spec. Okay? So we have the exclusive or the non-exclusive clusters. We have the similarity. We need to check the similarity. And we need to check the space. Whether you want to use the full space or you want to use the subspace. So you need to think how to do the analysis based on these four things. Mention two of the major clustering approaches. So there are 8 approaches. So the two approaches that we are going to learn today is the partitioning clustering and hierarchical clustering. Okay. So yeah, we will learn partitioning methods and hierarchical methods. Partitioning methods. What is partitioning methods? Partitioning a database D. Okay, we have a lot of data. We have a D database, and we have n objects. N objects. We call this n object or n rows. Okay. And we want to partitioning these n objects into a set of k clusters. K clusters. So K is a number of group that you want to create, such that the sum of square distance is minimized. So we will check later. P minus Ci. What is Ci? Ci is the centroid or the midway of the cluster of Ci. Okay, so we will check later. Even K. Find a partition of K clusters that optimize the chosen partitioning criteria. We can have the global optimal, but it exhaustively enumerate all partitions. So you need to calculate everything. So it is very high computation. We can use the heuristic methods. The heuristic methods means we will use this one, k-means and k-matrix. So k-means, it has been proposed in 67. But yeah, some people say it has been written in 57. Some of them, they develop it in 82 in more clear understanding. So each cluster is represented by the center of the cluster, so by the means. Or there's another method, we call it k-matrix or PAM. It is partition around matrix. So it has been developed in 87. So its cluster is represented by one of the objects in the clusters. So we will check about this. So the algorithm runs like this one. If you can see this, the iteration works from 1 and goes to 2, 3, 4, 5, and so on until 10. But maybe it's not until 10 only, it can be until many times. It depends when it stops. So the start is something like this one. Maybe it's better to see the example. I have this data. X1 and X2. So this is the X1 and this is the X2. Now the data 1 means where the X1 is 0.7 and the X2 is 0. 0.7 and the X2 is 0. So this is the data number 1. The data number 2 is when the X1 is 1 and the X2 is 0.4. Okay, the data number 2 when the X1 is 1 and the X2 is 0.4. The data number 3 is when the X1 equals to 0 and the X2 is 0.7. X1 is 0 and the X2 is 0.7. Okay. And so number 4 and number 5. Now I would like to have, I know that n equals to 5. And let's suppose I have k equals to 2. Okay, so I make this one. K equals to 2 means I want to make 2 groups. I want to make 2 clusters. So how can I make it? This is the plot. And I can try with the iteration number 1. The iteration number 1, I can just select randomly. Okay. And let's suppose I randomly select the object number 3 and 5. It will be in the same cluster. And the object in number 1 and number 2 and number 4, they are also in the same cluster. Now, with this iteration 1, I can calculate the centroid. What does it mean by centroid? Centroid is the center point. So the center point of object 1 and 2 and 4, 1 and 2 and 4, it means I will calculate this number 1 and 2 and 4 and then divide it by 3. So 0.7 plus 1.0 plus 0.3. And then we will divide it by 3. So we will get the value 2 divided by 3. 2 over 3. What about the x2? So this is the x1. Okay, this is the x1. What about the x2? The x2 is the same. The object 1 is 0 plus 0.4 plus 0.6. Because we have 3 objects, so we divide by 3. And this is the result, 1 over 3. So we call this is the centroid of the object for the cluster 1. Okay. What about centroid 2? The centroid 2 is the remaining, which is 3 and 5. Then we have 0 plus 0.4. Because we have only 2 objects, then we divide by 2. This one is the 0.7 and 1. We divide by 2, so we get this result. 0.2, 0.85. 0.85. Okay. So now we have the centroid. The next question is how we can measure the quality of this cluster. So we use the error formula. This formula means for every point, for every data, minus it with the centroid and square it. And after that, do the summation. So I would like to know, First, it is in the centroid one. The 0.7 is the object 1 minus 2 over 3. 2 over 3 is the centroid. So it means I want to know the distance from object 1 to the centroid, the distance object 2 to the centroid, and the distance of object 1 to the centroid. So this is 0.7 minus 2 over 3, and then 1.0 minus 2 over 3, which is the centroid, 0.3 minus 2 over 3, which is the centroid. And then we make it square. And then next, we have the x2. 0 minus 1 over 3, 0.4 minus 1 over 3, which is the centroid, 0.6 minus 1 over 3, which is the centroid. And then we again make it square. So we get these values, and okay, this is the error. What about the next one? The next one is the same. This is the data from the two objects, 3 and 5. Then the 0 minus by 0.2 square, 0.4 minus 0.2 and square. 0.7 minus by 0.85 square, and then 1 minus 0.85 square. So the result is this one, 0.125. Now we have the errors here and we have the errors here, so we can do the summation from the I equals to 1 until k. So we have k equals to 2. And the result is 0.4268 plus 0.125. Then this is the error. This is the total errors when you do these clusters. Did we finish? This is the finish for the iteration 1. So we need to check the next iteration, which is iteration 2. In the iteration 2, we need to select different group. So for example, now I'm choosing this group. Group 1 is the object 1 and 2. The group 2 is the object 3 and 4 and 5. So it's the same with the previous one. We need to check the centroid of the first object and the centroid of the second one. And we make the same centroid, which is 0.7 is from 1 plus 1 divided by 2. And then the second object is the 0 plus 0.4 divided by 2. Then we will get this value. And also the centroid 2, we have object 3, 4, 5. So it is 0 plus 0.3 plus 0.4 divided by 3. And then 0.7, 0.6, and 1 divided by 3. Oh, sorry. This should be 3. Sorry. This one should be 3. So we will get the value here. I think the value is okay. Yeah. Because the centroid, the first centroid is this one is this, and this one is here. Okay. Now, based on this one, I would like to check the error. Okay. Again, I can deduct for every of this one according to the centroid. According to the centroid, you can check the distance to the centroid. So 0.7 minus 0.85 square, 1 minus 0.85 square, 0 minus 0.2 square, and then 0.4 minus 0.2 square. So we get the value 0.125. And for the centroid 2, we also do the same, like this one and this one, and we can get this one. Next, we sum. What is the summation? Okay, the summation is this one, 0.3465. Because this is the error or this is the distance, so we want to find the smallest distance. What is the smallest distance? This one. Okay. Since the value is lower than the previous iteration, then we select this option. We select the minimum. Okay. This option is 0.34, but the previous one is 0.54. So we select the lowest. So we call this is the k-means. We want to find the means or the average of the object. The strength is it is efficient. If you learn the data structure, I think you know what is meaning by this big O. N is the number of objects, K is the number of clusters, and T is the number of iterations. If you look at this one, yeah, the iteration is the computation is linear. If you compare with the pump and the other kind of algorithm, Clara, so the other algorithm is square. So the square means more complex. But this algorithm often terminates at a local optimum. So there is no, sometimes we cannot find the global optimum. And other weaknesses is it is applicable only to continuous data, only to numbers, numerical data. What about categorical data? Yeah, we need to apply another algorithm. We call it K modes. So I will not explain K modes here. And we need to compare with other algorithm. We call it K matrix. So K matrix is usually applied to many other data. And the other weakness is we need to specify the K. Okay. Now we know that K equals to 2. But do you think 2 is the best? We don't know. So we need to again run when K equals to 3. Sometimes we need to run again when K equals to 4. When K equals to 4. So we need to find what's the best K. That's the weakness. And it is sensitive to noisy data and outliers. So if there is an outliers, like this one, if there's an outlier here, then it's sensitive. And it is not suitable to discover cluster with non-convection. Non-convex shape, it means like this one. It is convex, okay? It's circle. But if it is not in the good shape like this one, yeah, we call this is non-convex. Okay, I think I will stop here. So any questions, comments?